My name is Roger Summons. I am Professor of Geobiology at the Massachusetts Institute of Technology in Cambridge, Massachusetts. Well, my basic training is as an organic chemist. About 40 years ago I graduated from Wollongong University College, where I studied organic compounds in Australian native plants. And then in 2011 I wrote a proposal to be a participating scientist in the Mars Science Laboratory mission, which was about to launch for Mars, and fortunately I was funded to do that. And in that role I'm engaged with a large group of people working on the instrument called SAM. There's 9 or 10 instruments on MSL, and SAM is a gas chromatograph mass spectrometer, and its role is to look for small organic molecules in the soil of Mars. And so I've been working with that team since basically MSL launched, and particularly during late 2012 when MSL successfully landed on Mars, August the 6th, 2012. We spent the first 3 months in Pasadena working at the Jet Propulsion Laboratory and taking MSL, or taking Curiosity rover, through its early paces. And Curiosity, as you probably know, is still working, exploring the surface of Mars at Gale Crater. The role or the purpose of the Mars Science Laboratory is to investigate an area of Mars for habitability. So it's not a search for life, but it's a search for the conditions that, or conditions under which life could successfully proliferate. And life needs water, it needs the elements carbon, hydrogen, oxygen, nitrogen, phosphorus, and certain metals. And one of the things that characterises life on Earth is it makes organic molecules from simple building blocks. So if we can find the simple building blocks, any of the simple building blocks of life on Mars, then that would potentially be a sign that Mars has been habitable in the past. Our role is to design experiments and conduct them in ways that answer questions. So the hunch, you might be able to express the hunch as a hypothesis. Yes, there are habitable environments on Mars, and then your goal as a scientist is to design experiments that will disprove the hunch, not prove the hunch, but disprove the hunch. At designated period during the day, we phone into JPL and people have a conversation about what's the best plan for the day, and of course that depends on where the rover is, where it's situated, what sort of information it has to describe or understand the environment that it's in. The most critical instruments in that respect are the cameras. So there are several large cameras. There are what we call HAZCAMs. They're the cameras that the rover uses to make sure it doesn't trip over big boulders. And there's a hand lens imager, so it's basically like a geologist's hand lens that can look at very fine scale features of rocks. So basically the steps are that the rover would approach a rock, it would photograph the rock in different ways, it would use its chemistry instruments to remotely query the rock for its elemental composition, and then it would do what's called contact science. That is, it might drill a hole, it might take a sample from the drilling, put it in its internal instruments, which are called SAM and ChemIn, and through those analyses it can basically look for small organic molecules. It can understand the mineralogy, that's the minerals that comprise the rock. Many experiments are being done on Mars' atmosphere because that's an important part of evaluating habitability. Mars' atmosphere is very thin, but it's very important for life that there is at least some atmosphere, because that atmosphere moderates cosmic rays coming from the sun. So analysis of the atmosphere is an important role, and particularly to analyse the atmosphere over a significant period of time, because you take one snapshot of the atmospheric composition, well, you'll learn something, but you might learn a lot more if you can follow changes in the composition of the atmospheric gases through time, for example. When I graduated, I had absolutely no idea that I would end up with the career I've got. It's one of the great joys, I think, of a life in science, that you follow a path determined by your curiosity, really. It's following a path where you see something that you're interested in, you explore it, you investigate it, you study it. That leads generally to more questions than answers, and then following those questions in turn leads you down this very exciting pathway of exploring the planet, which is what people have done since the beginning of time, really.